In today's lecture, we will continue with our studies on matrices. In the previous video, that is Matrices Chapter 3 Part A, we studied about types of matrices, operation on matrices, transposition of matrix, symmetric and skew symmetric type of matrices, and invertible type matrices. In the previous video, that is 3A, we also solved 1-mark question. In this video, that is chapter 3 part B, we will solve question and answers of 3 marks and 2 marks. As you know, the syllabus for the year 2 marks and 3 marks questions, that is short answer type questions. Question number 1. Radha, Fauzia and Simran are students of 12th class. Radha has 15 notebooks and 6 pens. Simran has 13 books and 5 pens. The question is, express this into matrix form. Let us answer it. Answer. So, we will write the students in row and books in column 1 and pens in column 2. So the first student is here, the given name is Radha. Radha has 15 notebooks and 6 pens. So it is written 15 notebooks and 6 pens. This is for Radha. And for Fauzia, the items are written in row 2. Therefore, she has 10 books and 2 pens. So it is written in row 2, column 1 is books, notebooks, and column 2 is pens. So in the row 3, we will write for Simran. Simran has 13 books and 5 pens. So it is expressed. Their notebooks and pens are written in column 1 and column 2 respectively. Students are in row. This can also be written in other form. Students can be written in column. There are 3 students, so there are 3 columns. This is first column, this is second column, and this is third column. There are 2 items. One is notebook. Notebook is written on row 1 and pens are written in row 2. So this is the expression of in the matrix form. Question number 2. Find x, y, z from the equation. It is given in a matrix. First row is x plus y plus z. Second row is x plus z. And third row is y plus z. And you close the bracket as usual for a matrix. And it is given on the right hand side 9, 5, 7. So there is 3 rows. There are 3 rows and 1 column. Similarly, on the right hand side, there are 3 rows. 9 is 1 row, 5 is 1 row, 7 is third row. So column is 1 only, 9, 5, 7. So it is 3 by 1 and right side also 3 by 1. So comparing the elements of left hand side with right hand side, we get x plus y plus z is equal to 9. X plus z is equal to 5 and y plus z is equal to 7. From this we have to get the values of x, y and z by simultaneous equation method or substitution method. So x is equal to 9 minus y plus z. But we know y plus z is equal to 7. Therefore 9 minus 7 is equal to 2. And next it is given x plus z is equal to 5. We know from the previous equation x is equal to 2. Therefore z is equal to 5 minus 2. That is equal to 3. Therefore z is equal to 3. Now from this third item, third element, y plus z is equal to 7. Therefore y will be equal to 7 minus z. Z's value we have found from the previous part, that is minus 3. Z is equal to minus 3. Therefore y is equal to 4. Hence x is equal to 2, z is equal to 3 and y is equal to 4 is the answer. Next problem. Find A, B, C and D from the equation. So, this is a matrix. The matrix is given. A minus B. First row is A minus B. First element. Second element is 2A plus C. Second row is 2A minus B. And last element is 3C plus D. This is given matrix. That is also, they have also given equal to right hand side matrix is minus 1, 5, 0 and 3. Minus 1 and 5 in row 1 and 0 and 13 is the row 2. Hence, we have to find, the question is find A, B, C and D from this equation. Let us solve it. Answer. Comparing the elements of both the matrices, that is left hand side matrix and right hand side matrix, we get A minus B is equal to minus 1. Okay. 2A minus B is equal to 0. Therefore, B is equal to 2A. From this, if you take B is equal to right hand side B is equal to 2A. Therefore, if B is equal to 2A, we put 2A, A minus 2A, that is minus of A. Minus of A is equal to minus 1. Therefore, A is equal to 1. Similarly, if you put A is equal to 1 in this, B will be equal to 2. Now, we compare 2A plus C is equal to 5. You see, this is the first row, second element is first row, second element on the right hand side. 2A plus C is equal to 5. Therefore, C is equal to 5 minus 2A. So, A value we have found as 1. So, therefore, C will be equal to 5 minus 2, that is equal to 3. So, again we have 3C plus D comparing the last element, that is 3 plus C plus D equals 13 from this comparison. 3C plus D is equal to 13. Therefore, D will be equal to 13 minus 3C. So, if you substitute the value of C as 3, which we have found in the previous line, so 13 minus 3 into 3 is 9. So 13 minus 9 will be equal to 4. So hence A is equal to 1, B is equal to 2, C is equal to 3 and D is equal to 4 is our answer. Next question. Question number 4. Construct 3 by 4 matrix whose elements are given by Aij is equal to 2i minus j. Please read it carefully. We have to construct a matrix of 3 rows and 4 columns whose elements are Aij. Each element is defined as Aij is equal to 2i minus j. We have to construct. Here we have to put I is the row and j is the column. Column number. I is the row number and j is the column number. Let us solve it. Answer. So, A11. Here A11, put I is equal to 1 and j is equal to 1. Therefore, we get 2i is 2 into 1 minus 2, 1. Here j is 1. Therefore, j is 1. So, 2i is 2 minus of j is 1. That is equal to 1. That is element 1, 1. First row and first column will be 1. Similarly, we can put for the next element, that is row 1 and column 2. We get A12 equals 0. A13, this is first row, third column. So, therefore, first row is 2, I is 2 minus, that is 2 into 1 is 2 minus j is third column is 3. Therefore, 2 minus 3 is minus 1. Okay, we have to substitute all values in the equation Aij is equal to 2i minus j. Like that, we can write for all other items till we get 12 items. Therefore, there will be total number of 12 items. 3 into 4 is 12. So, we have to substitute up to all items, 12 items we have to. Question number 5. Construct 3 by 4 matrix whose elements are given by Aij. We have to form a matrix of 3 rows and 4 columns whose elements are given by the relationship Aij is equal to half of absolute value of minus 3i plus j. Let us solve it. Given Aij is equal to mod of minus 3i plus j divided by 2. For each element in the matrix, we had to substitute the values of I and j, where I is the row number and j is the column number. Let us solve it. Put I is equal to 1 and j is equal to 1. That is the first element of the matrix, where A11 will be the first element. That is equal to mod of minus 3 into I is 1 plus 1 divided by 2. That is equal to minus 2 divided by 2. That is equal to the first element is A11, that is 1. For differentiating, we have given in red color, so that you have to write this number inside the matrix. Similarly, in the next item, we will put I is equal to 1 and j is equal to 2. That is the first column and second row. So, substituting and taking the absolute value, we get A12 as equal to 12. You please write and practice it and calculate the absolute value of A12 by putting value of I as 1 and j is equal to 2. Similarly, the next value for I is equal to 1 and j is equal to 3, we get the A13 equals 0. And for values of I equal to 1 and j is equal to 4, A14 is half. Next value is A21, element A21. Its value has been calculated as 5 by 2, which is given in red color on the right hand side. This red color is only for identifying these values. Otherwise, in your examination, you have to use the permissible ink, that is blue or black. So, for AI22, the value is 2. And for AI2 and J3, the value of A23 is 3 by 2. And for A24, the value is 1. And for A31, the value of element is 4. For A32, the element is 7 by 2. For A33, the value is 3. And for A34, that is row number 3, column number 4, the value is 5 by 2. Therefore, the matrix asked in the question is A suffix 3 by 4, that is 3 columns, 3 rows and 4 columns is here. We have substituted the calculated values in this manner. This is A11, A12, A13 and A14. This is A21, A22, A23, A24. Then A31, A32 and A33 and A34. Hence, this is 3 rows and 4 columns. Next question, question number 6. If A is equal to a matrix, it is given in the matrix 8, 0, 4, minus 2, 3, 6, close the bracket, and B is equal to 2, minus 2, 4, 2, minus 5, 1 within square bracket. Find x such that 2a plus 3x is equal to 5b. Please see here, the matrix A is 3 by 2, 3 rows and 2 columns. B is also 3 rows, 2 columns. Hence, we can do additions. So, here such that the condition is 2a. That means the vector A should be multiplied by a scalar quantity 2 and the matrix B should be multiplied by scalar number 3 such that we have to prove that it is equal to 5b. Let us solve it. Given. So, given here 3x. 3x we are not knowing. So, 3x is equal to, we can rewrite the given equation as 5b minus 2a. And this becomes x is equal to 5b minus 2a divided by 3. This we have to calculate using the given matrix. Now let us find out the term here 2a, that is the extreme right term is minus 2a. Now we will find 2a. 2a is equal to 2 into a is 80, 4 minus 2, 36. That is equal to, we have to multiply each element of a by a scalar number 2. Therefore, it is 16, 0, 8 minus 4, 6 and 12. That is 2 into 8 is 60, 2 into 0 is 0, 2 into 4 is 8, 2 into minus 2 is minus 4, 2 into 3 is 6 and 2 into 6 is 12. So, we have found 2a. Now, let us calculate let us form the matrix 5b. 5b, b is given as 2 minus 2, 4, 2, minus 5, 1. As it is, whatever is given, and that has to be multiplied by a scalar number 5. So, let us do it. 10 minus 2. 2 into 5 is 10. Minus 2 into 5 is minus 10. 4 into 5 is 20. 2 into 5 is 10. 5 into minus 5 is minus 25 and 5 into 1 is 5. So, now we have got values of 5b and 2a. Now, as per the given equation, we have to subtract 2a from 5b. Let us calculate 5b minus 2a. Therefore, 5b minus 2a is, we have to subtract the corresponding elements of 2a from vector 5b. So, 10 minus 16 is minus 6. Minus 10 minus 0 is minus 10. 20 minus 8 is 12. 10 minus of minus 4 is 10 plus 4, 14. Minus 25 minus 6 is minus 31. And 5 minus 12 is minus 7. So, we have calculated a step 5b minus 2a. Now, we have to find 3x. Therefore, x will be equal to 5b minus 2a divided by 3. So, we have to divide this vector by 3. Hence, all the elements should be divided by number 3. Therefore, it is minus 6 by 3, minus 10 by 3, 12 by 3, 14 by 3, minus 31 by 3 and minus 7 by 3. Question number 7. Find x and y if 2 into matrix x 5, 7, y minus 3 plus matrix 3 minus 4, 1, 2 is equal to, on the right hand side, matrix 7, 6, 15, 14. So, we have to solve for x and y in the 3 matrices. That is the equation given in terms of 3 matrices. The first matrix on the left hand side, 2 into matrix x 5, 7, y minus 3 plus another matrix 3 minus 4, 1, 2 equals the right hand side matrix. So on the left hand side, we have to make a scalar product 2 into this matrix, the first matrix, plus addition with the second matrix. Let us do it. So first scalar product 2 into x, first element 2 into 5, that is 10, 2 into 7, 14, then 2 into y, 2y, minus 2 into 3, 2 into minus 3 is minus 6. So we have completed scalar multiplication on the first matrix. Then the second matrix we will copy as it is. That is 3 minus 4, 1, 2. On the right hand side, the matrix, given matrix is also written. Now we will perform the next step, addition of two matrices on the left hand side. Therefore, 2x plus 3, then 10 minus 4, 14 plus 1, and the last item is 2y minus 6 plus 2. That is equal to matrix on the right hand side, 7, 6, 15, 14. Now, the next step is to compare the elements of matrix on the left hand side with the elements of matrix on the right hand side. Therefore, 2x plus 3 is equal to 7. Here, comparing, the first element is 2x plus 3 and the right hand side is 7. Therefore, 2x plus 3 is equal to 7. Or solving for x, we get x is equal to 2. Similarly, in the next step, we will compare the element, that is the fourth element having y, that is 2y minus 4 equals 14, the element on the right hand side. Therefore, 2y is equal to 14 plus 4, or that is 18, or y is equal to 18 by 2 equals 9. Hence, we have found the values of x and y. Next problem. Find x and y if x into matrix 2, 3 plus y into matrix minus 1, 1 equals 10 and 5. Let us analyze this problem. Here, x is a scalar multiplication factor into x into 2, 3 plus y into y is also is unknown value we have to find minus 1 and 2. And the right hand side we have 10 and 5. This is a 2 by 1 matrix and this is also 2 by 1 and right side also 2 by 1. Let us do it. Therefore, scalar product of x into 2 matrix 2, 3. Therefore, we get 2 into x is 2x, 3 into x is 3x, plus y into minus y is minus y, and y into 1 is y within big bracket. That is equal to 10 and 5. Now, in the next step, we have to add the first matrix on the left hand side plus second matrix on the left hand side. We will do it. Therefore, 2x minus y, 3x plus y are the elements of the new matrix after addition. Therefore, that is equal to 10 and 5. Therefore, 2x comparing the elements of matrix on the left hand side and the elements of matrix on the right hand side, we get 2x minus y is equal to 10 and 3x plus y is equal to 5. We can find out the value of x and y by simultaneous equation method. Therefore, adding equation 1 and 2, we get 3 plus 2x, 2x plus 3x is equal to 5x is equal to 10 plus 5, that is equal to 15. Hence, x will be equal to 15 by 3. That is equal to 3. We have found the value of x. Now we will proceed to find the value of y. Therefore, from equation, we will write once again 2x minus y is equal to 10. Therefore, 2x is equal to, taking y on the right hand side, we get 10 plus y. Or y is equal to 2x minus 10. But we know the value of x we have found previously is 3. X is equal to 3. Therefore, y is equal to 2 into 3 minus 10. Therefore, it will be 6 minus 10, that is 4, or y is equal to 4. Let us solve the next problem. Given 3 into xy zw is equal to x 6 minus 1 2w plus matrix 4 x plus y z plus w and 3. We have to find the values of x, y, z and w. We have to, with this given matrix, given equation of matrix, we have to find the values of 4 unknown elements x, y, z and w. Let us do it. Therefore, first here it is a scalar product, that is 3 into x, y, z, w. Hence, if we multiply with 3, we get 3x, 3y, 3z and 3w. That is the matrix on the left hand side. On the right hand side, we have to perform addition of two matrices. Each matrix is of the order of 2 by 2. Hence, we can add it. Therefore, x plus 4 is the first element. 6 plus x plus y is the next element. And here in the second row, we get minus 1 plus z plus w. So, we get minus 1 plus z plus w. The next element is 2w plus 3. 2w plus 3 is written here. Therefore, comparing the elements of matrix on the left hand side and right hand side, we get 3x is equal to x plus 4, or x is equal to 2. That is 3x minus x is 2x, 2x is equal to 4, or x is equal to 4 by 2 and x is 2. Next, we will have 3y is equal to 6 plus x plus y. Here we have written 3y is equal to 6 plus x plus y. This is from this element. Or substituting the value of x as 2, we get 3y is equal to 8 plus y, or if we shift y on the left hand side, 3y minus y becomes 2y. 2y is equal to 8, or y is equal to 4. The next step is we compare the fourth element, that is 3w is equal to 2w plus 3. Therefore, 3w equals 2w plus 3, or w is equal to, so 3w minus w is equal to 3. So, we have found the values of x is equal to 2, y is equal to 4 and w is equal to 3. Next, we have to find the value of z. So, we will use for this, we will use the equation 3z is equal to, that is the first element on the second row, 3z is equal to minus 1 plus z plus w. Or if we shift 3z minus z, that is 2z is equal to minus 1 plus w. W we have calculated previously as 3. Therefore, minus 1 plus w is minus 1 plus 3. Therefore, 2z will be is equal to 2, or z will be equal to 1. Thus, we have solved the problem and our answer is x is equal to 2, y is equal to 4 and w is equal to 3 and z is equal to 1. We will take the next example. Example number 10. If A is equal to 3 minus 2, 4 minus 2 and I is equal to 1, 0, 0, 1, find K if A square is equal to Ka minus 2i. So, please examine this equation. A is 2 is of the order of 2 by 2, where 2 rows and 2 columns are there. I is the identity matrix of 2 by 2. And we have to find the value of K such that the equation, it satisfies the equation A square is equal to Ka minus 2i. So here we have to first step is find the A square. A square is found by multiplying matrix A by A. Let us do it. So given matrix is written as it is. So we have to find A into A, and A into A is 3 minus 2, 4 minus 2 into 3 minus 2, 4 minus 2. Therefore, we multiply horizontal. First row multiplication is multiplication first row into first column. That is the first element. 3 into 3 is 9. Minus 2 into 4 is minus 8. So 9 minus 8 is the first element. The next element is found by multiplying first row with the second column. This is the second column. Therefore, we get 3 into minus 2 is minus 6. Minus 2 into minus 2 is plus 4. So, second element we got. Now, the next step is to multiply second row of the first matrix with the first column of the second matrix. Therefore, it is 4 into 3 is 12, minus 2 into 4 is minus 8. And the next step is multiplying the second row with the second column. Therefore, 4 into minus 2 is minus 8. Minus 2 into minus 2 is plus 4. So, we have got all the 4 elements of new matrix A square. Now, we will write the given equation. That is, A square is equal to Ka minus 2i. Therefore, A square we have found, you have simplified here, 9 minus 8 is 1, minus 6 plus 4 is minus 2, 12 minus 8 is 4, minus 8 plus 4 is minus 4, equal to K is a scalar, into A, the given matrix, that is 3 minus 2, 4 minus 2, that is given matrix is written here, K into A minus the given equation. The 2 is a scalar and it has to be multiplied by the identity matrix I, which is 1, 0, 0, 1. Therefore, simplifying, we get 1 minus 2, 4 minus 4 is equal to K into 3 is 3K, K into minus 2, minus 2K, K into 4 is 4K, K into minus 2 is minus 2K. And we have to perform again the subtraction of the left matrix and second matrix. So, second matrix is 2, 0, 0, 2. That is scalar multiplication. Then we get 3K minus 2 and minus 2K plus 0 and 4K plus 0 and minus 2K minus 2. This is we have written here. So, comparing the equation, we get here you see minus 2K is equal to minus 2 or K is equal to 1. Hence, we have solved this problem. Question number 11. If A is equal to matrix 3, root 3, 2, 4, 2 and 0 and B is equal to 2 minus 1, 2, 1, 2, 4, verify A plus B dash is equal to A dash plus B dash. Here, please examine the matrices first. It is 2 by 3 and the second one is also 2 by 3. Hence, addition can be done. And we have to add, first step, we have to add A and B and find its transpose. That is A plus B dash. Then individually, we have to transpose. A should be converted into A dash and B should be converted into B dash. In transposition, we interchange rows by columns and rows by columns in both sides. Let us do it. Given A is equal to 3 root 3 2 and B as it is 4 2 0. B is also written in the same way. Therefore, we will add A plus B, that is 3 plus 2 is 5, root 3 minus 1 and 2 into 2 plus 2 is 4. And similarly, 4 plus 1 is 5, 2 plus 2 is 4 and 0 plus 4 is 4. Next, we will find the transpose of A plus B as A plus B dash. Therefore, the row is 5 is converted into column. Hence, we have written 5 root 3 minus 1 and 4. That is, row is written as a column. And similarly, for second row, it is 5, 4 and 4. Hence, we have transposed A plus B. Next step is we have to find individual transpositions. That is, A should be transformed to transpose to A dash. Therefore, A dash is A is 3 root 3 2. Therefore, it is 3 root 3 2 and 4 2 0 and column is 4 2 0. Similarly, B dash is 2 minus 1 2 and this will be written as a column 2 minus 1 2. And second row is second column. Therefore, 1, 2, 4, 1, 2, 4. So now we have found A plus B within brackets dash and A dash and B dash. Now we have to compare. We have to add A dash plus B dash. Therefore, A dash plus B dash will be equal to 3 plus 2 is 5, 4 plus 1 is 5, root 3 minus 1 and 2 plus 2 is 4 and 2 plus 2 is 4 and 0 plus 4 is 4. Hence, we have proved that A dash plus B dash is equal to A plus B within brackets to dash by comparison. Hence, the answer. Next problem. Problem number 12. Theorem 1. This is a theorem. Here we have to prove that for any matrix A with real number entries, that is matrix A is with real number entries, A plus A dash is symmetric matrix and A minus A dash is skew matrix. So we have to perform two things. One is we have to find the symmetric matrix by adding A plus A dash and then we have to prove it as a skew matrix by subtraction of A dash from A. Let us do it. First step is to find the matrix A and its transpose. So let B is equal to A plus A dash. Then B dash, if we take, B dash is equal to A plus A dash whole to the power of dash. Then A dash individually, A dash plus A dash of dash is, we have written here, because we know the property of transposition, A plus B whole to the power of dash is equal to A dash plus B dash. That we have written here. The next step is A dash plus A dash of dash is A. Therefore, that is nothing but B. Hence, A plus A dash is symmetric. Now, for skew matrix, let us consider a matrix C such that C is equal to A minus A dash. Therefore, C dash by transposition we find C dash is equal to A minus A dash of whole dash. Therefore, that is equal to A dash minus A dash of dash. Therefore, it is A dash minus A. That is A dash within bracket to the power of dash is A. Therefore, if we take shift A here, minus sign outside, this becomes A minus A dash. That is nothing but minus C dash. That is equal to minus of C. Therefore, C dash is equal to minus C. Hence, A minus A dash is a skew matrix. Next question number 13. For any matrix A equals 1, 5, 6, 7, verify that A plus A dash is symmetric matrix. Previously, we proved the theorem using alphabets. In this, we have to consider the numerical problems where A is equal to 1, 5, 6, 7. Let us do it. A is written as given. Hence, A dash is found by transposing, by changing rows by columns. Therefore, 1, 5 becomes column 1, 5. Row 1, 5 becomes 1, 5 column of A dash. Similarly, the second row, 6, 7 becomes the second column, 6 and 7. It is written here. Next, therefore, A plus A dash is equal to 1 plus 1 is equal to 2. 5 plus 6 is 11, 6 plus 5 is 11, and 7 plus 7 is 14. Thus, we have transposed matrix A to A dash, and then again we have found the sum, addition of A plus A dash, and we have got a new matrix. Now, A plus A, now we will again transpose the new matrix. A plus A dash is dash. So, row is converted into column. Therefore, 2, 11 becomes column and 11, 14 also becomes column. So, A plus A dash whole dash, 2, 11 and 11, 14. Hence, A plus A dash is a symmetric matrix. That is, A plus A dash is equal to A plus A dash whole dash. Both are same. Hence, it is a symmetric matrix. Now, question number 14. For any matrix A equals 1, 5, 6, 7, verify that A minus A dash is skew matrix. That is, we have to find A minus A dash is equal to minus A. So, let us do it. Please see, this matrix is a 2 by 2 matrix. Given matrix is written as it is. Therefore, we will transform A to A dash. That is, transpose, not transform, transpose. 1, 5 becomes column. 6, 7 also becomes column. Therefore, A dash is equal to 1, 6 and 5, 7. Therefore, let B is equal to A minus A dash. So, now we have to perform subtraction. A minus A dash. That is equal to 1 minus 1 is 0. 5 minus 6 is minus 1. 6 minus 5 is 1. And 7 minus 7 is 0. Now, B dash is 0, minus 1 and 0. we have transformed. That is 0 minus 1 becomes column and 1 0 becomes the second column of B dash by transposing. Therefore, taking minus 1 common, if you take minus 1 common, it becomes 0, minus 1, 1 and 0. Therefore, B dash is equal to minus of 0, minus 1, 1, 0. Hence, if you compare this matrix with matrix B, it is minus of matrix B. Hence, it is a skew matrix. Therefore, B dash is equal to minus B. It is a skew matrix. Question number 50. It is a theorem. If A and B are invertible matrices of same order, then prove that AB to the power of minus 1 equals B to the power of minus 1 and A to the power of minus 1. Please remember, A to the power of minus 1 is inverse of matrix AB. B to the power of minus 1 is the inverse of matrix B. And A is to the power of minus 1 is the inverse of matrix A. Let us do it. From the definition of inverse of a matrix, we have AB into AB whole to the power of minus 1 is equal to I, where I is the identity matrix, AB is the product of matrix A and B, AB whole to the power of minus 1 is the inverse of matrix AB. Therefore, pre-multiplying both sides by A to the power of minus 1. That is, we are multiplying by inverse of matrix A. Therefore, A to the power of minus 1 into AB into AB to the power of minus 1 is equal to A to the power of minus 1 into I. The both sides we have A to the power of minus 1. Left hand side as well as right hand side. Therefore, we get A to the power of minus 1 into A into B. You see here multiplying A to the power of minus 1 into A within brackets and B is outside the bracket, and AB to the power of minus 1 as it is equal to A to the power of minus 1. So, because we know A to the power of inverse of A is nothing but A to the power of minus 1 into I is equal to A to the power of minus 1. Therefore, we get A to the power of minus 1 into A is I and B as it is AB to the power of minus 1, that is equal to A to the power of minus 1. Therefore, it becomes IB into B, I into B is B, AB to the power of minus 1 retained and right side is also same. Therefore, now we will multiply both sides by B to the power of minus 1. Previously, we multiplied with A to the power of minus 1. Now we will multiply both sides by B to the power of minus 1. Therefore, it is B to the power of minus 1 into B into AB whole to the power of minus 1. That it becomes on the right hand side B to the power of minus 1 into A to the power of minus 1. That is, we have multiplied with B to the power of minus 1. We know B to the power of minus 1 into B is I. That is inverse into AB to the power of minus 1 equals B to the power of minus 1 into A to the power of minus 1. Hence, AB to the power of minus 1 equals, we know I into A is A to the power of 1. I into A to the power minus 1 is equal to A into the power minus 1. That is, I into AB to the power of minus 1 is equal to AB to the power of minus 1. That is equal to B to the power of minus 1, A to the power of minus 1. Hence, we have proved it. Question number 16. By using elementary operation, find the inverse of matrix within brackets 1, 2, 2 minus 1. So we have to find the inverse of the given matrix by using elementary operations. Given A is equal to 1. So we know from our knowledge of elementary operations, inverse operations, A is equal to, by definition, A is equal to IA, where I, the identity matrix, is 1, 0, 0, 1. Therefore, substituting the values of A, 1, 2, 2 minus 1, on the right side, the identity matrix 1, 0, 0, 1 into A. So, our main approach is to make this an identity matrix, left hand side, that is 1, 0, 0, 1. So, that is the value here, we should bring it here by performing transformation operations. So, this A21 should become 0. Therefore, we will do certain operation, that is R2, applying R on R2, R2 minus 2R2. So, R2 is 2 here and 2R1 is minus 2. The 2 minus 2 is 0. So, we got A21 0 and the values on the next element will change. Therefore, minus 1 here, R2 is minus 1, minus of 2R2 is minus 4. That becomes minus 1 minus 4 is minus 5. On the right hand side, we have to repeat the same operations. 1 and 0 in the first row will be retained as it is, and we are doing operations on R2, row 2 only. Therefore, 0 minus 2 is minus 2 and 1 minus 0 is 1 only into A. Next operation, next approach is we have to make this minus 5 as 1 because 1 is here. We have to make this also as 1. This can be done by multiplying with minus 1 by 5. So that is R2 into minus 1 by 5 in R2 only. Therefore, in row 2, A22 should be 1. Therefore, minus 5 should become 1. Therefore, R2 applying R2 into minus 1 by 5. 0 into minus 1 by 5 is 0. Minus 5 into minus 1 by 5 is plus 1. So, R22 has become 1. And the right hand side, we have to do the similar operation. So, minus 2 into minus 1 by 5 is plus 2 by 5. And 1 into minus 1 by 5 is minus 5. Minus 1 by 5. Now, next thing is we have to make this in row 1, this as 0. This we can do it by subtracting R1 minus 2R2. So, if we subtract 2R2, it becomes 0. Let us do it. Therefore, A12 is 0, R1 is R1 minus 2R2. Therefore, it is 2 minus of 2R2, 2 minus 2, that becomes 0. Therefore, this is 1 minus 2 of 2 by 5, 1 minus 4 by 5. Therefore, that becomes 1 by 5. 1 by 5. And then this has to be right hand side. This also 0 minus 2R2. 0 minus of into minus 2R2 is 2 by 5. This becomes 2 by 5. And the row 2 remains as it is. Now we have got 1, 0, 0, 1. Therefore, this matrix, this is the inverse. Therefore, I is equal to A inverse of A. So, this is inverse matrix. That is given here. A to the power of minus 1 is equal to 1 by 5, 2 by 5, 2 by 5 and minus 1 by 5. That is the answer. Next question. 17. By using elementary operation, find the inverse of matrix 1 minus 1, 2, 3. Let us do it. Given matrix is written as it is, and we know A is equal to IA. We have to always write A is equal to IA only, where I is the identity matrix given by 1, 0, 0, 1. Therefore, 1 minus 1, 2, 3 is equal to 1, 0, 0, 1, substituting the values. Now we have to make this as a 0. Compare it 0 and this also 0 and this also 3 operations. First operation make this 0. Next operation is make this 1 and next operation make this 0. Let us do it. So let us perform. A21 is 0, R2 is equal to R2 minus 2R2. Therefore, R2 is 2 here, 2 of R1 is minus 2. 2 minus 2R1, 2 into 1 is 0. So it becomes 0. Therefore, 3 minus into minus is plus 2. 3 plus 2 is 5. And on right hand side, 1 and 0 as it is. This is 0. 0 minus 2R1 is 2 minus 2. Therefore, this becomes minus 2. And this one, 1, this one becomes R2 is 1 minus of 2R1. Minus of 2R1 is 0. Therefore, this is 1 only. So, next step is to make R2 to 1. Here we have to make 1. To make it 1, we have to multiply it by 5. 1 by 5 or divide it by 5. Therefore, this becomes left hand side 1 minus 1 as it is 0. 0 into 1 by 5 is 0 only and R2 is 5. 5 by 5 is 1. Therefore, it is 1. On the right hand side, we have to perform the same operation. 1, 0 as it is. Minus 2 is there. We have to multiply it by 1 by 5. That is 1 by 5. That becomes minus 2 by 5. And the next element is 1 by 5. Therefore, now we have to make this as 0. 1 is there. We have to make it 0. In order to do it, we will add R1 plus R2. That is operation 1. If you add 1, this becomes 0. Therefore, R1 plus R2 is 0. And the first equation, and 1 plus 0 is 1 only. And therefore, 1 plus R2, that is 1 minus 2 by 5. That becomes 3 by 5. And 0 plus 1 by 5 is 1 by 5. R2 is as it is. Now we have got 1, 0, 0, 1 on the left hand side. So this matrix, that is 3 by 5, 1 by 5, minus 2 by 5 and 1 by 5 is A inverse. That is the answer. So we have done this problem. Question number 18. By using elementary operation, find the inverse of matrix within brackets 1 minus 2, 2, 1. Let us solve it. It is similar to the previous problem. Slight changes in sign. So we know A is equal to IA, where I is equal to identity matrix 1, 0, 0. Therefore, substituting the values of A and I, we get 1 minus 2, 2, 1, 1, 0, 0, 1 into A. Therefore, by using elementary operations, we have to make A to 1 as 0 by applying R2 minus 2R1 on row 2. Therefore, we get 1 minus 2, first row as it is, 2 minus of 2r1, that is 2 minus 2r1 is 0, and 1 minus of 2 into 2 is, we get 5. On the right hand side we get 1 0 minus 2 1 into a. The next operation is to make a2 to 1. So we can do it r2 into 1 by 5. Therefore 1 minus 2 as it is 0. 5 into 1 by 5 is 1. On the right hand side it is minus 2 by 5 and 1 by 5. Now next step will be to make this a1 to 0. Here we have to make it 0 by suitable operations, elementary operations. Let us apply. Therefore, this is done on row 1. Operation has to be obviously on row 1. Therefore, R1 will be equal to R1 plus 2R2. Therefore, it will be 1 plus 0. Therefore, it is 1. Therefore, this will be minus 2 plus of 2 into 1. This becomes 0. The same operation has to be done on the right hand side. Therefore, it will be 1 by 5, that is 1 plus 2 into R2. Plus into minus is minus 4 by 5. Therefore, 5 minus 4 is 1, 1 by 5. And the right hand side will be 0 plus 0 plus 2 into R2. That is 2 into 5 by 2. Therefore, it becomes 2 by 5. Therefore, we have got all the elements on the left hand side. 1 0 0 1 equals 1 by 5, 2 by 5, minus 2 by 5, 1 by 5 into a. This becomes a inverse. This is a inverse. Therefore, a inverse is equal to 1 by 5, 2 by 5, minus 2 by 5 and 1 by 5 is the operation. This is the inverse of a. Next question. Find p to the power of minus 1, that is p inverse. If it exists, we have to first find out whether it is existing, and p is equal to given by 10 minus 2 minus 5 and 1. Given p is equal to 10 minus 2 minus 5 1 as it is, and therefore p is equal to I into p. We know for inverse function relation is p is equal to ip, where I is equal to identity matrix 1 0 and 0 1. Therefore, we get 10 minus 2 minus 5 1, that is equal to identity matrix 1 0 0 1 into p. Hence, we perform binary operations to make these elements 0 on the row 1. And so let us make it on this. Therefore, row 1 we will divide by 10, that is R1 by 10. So 10 by 10 is 1. Minus 2 by 10 is minus 1 by 5. Minus 5 and 1 as it is. And the right hand side 1 by 10 and 0 as it is. The 0 into R1 by 10 is 0. And the second row R2 remains as it is into P. Now another operation we have to perform to make this 0. Let us do it. Therefore, R2 will be equal to R2 plus 5R1. That is, we have to make this as 0. Therefore, 1 R2 is minus 5 plus 5R1 plus 5 into R1 is 1. Therefore, it becomes 0. And this element R2 is 1 here plus 5 into minus 1 by 5. Therefore, it will be 5 gets cancelled. It becomes 1. 1 minus 1 is 0. Therefore, on the right hand side, we get first row as it is 1 by 10 0, and this will be R2 is 0 plus 5R1. 5R1 is 1 by 2. So this becomes 1 by 2. And here we get R2 is 1 plus 5 times R1. 5 times 0. Therefore it is 1. Now we see there are the row, second row, both the elements are 0. 0 and 0. Hence, we have all zeros in second row. Therefore, this is 0, 0 of left hand side matrix. Therefore, P inverse does not exist. This is the answer. So, we have found that P inverse does not exist. Question number 20. A equals 3, 1, minus 1, 2. Show that A square minus 5A plus 7I equals 0. A is given. So we have to find A square. That is 3 into 1. A into A is A square. 3, 1, minus 1, 2. 3, 1, minus 1, 2. We have to multiply. That is first row by first column. First row by second column. And second row by first column. Second row by second column. We will do it. Therefore, doing it, we get 9 minus 1. 3, that is 9 minus 1, and then 3 plus 2, that is the first row into second column. 3 minus plus 2, and the next column is second row into first column. Minus into 3 is minus 3, minus that is 2 into 2 into minus 1 is minus 1. Then next is second row, second column. That is minus 1 into 1 is minus 1. 2 into 2 is 4. A square value we have got. Therefore, now A square and 5A we have to find out. Therefore, A square is as it is 5 times A. 5 into A. We have substituted the A matrix A as it is minus 7I. I we know I is the identity matrix, so 1 0 0 1. Hence we get 9 minus 1 8, 5 minus 4 and plus 3. Minus of 5 into 3 is 15. 5 into 1 is 5. 5 minus 1 is 5 into minus 1 is minus 5. 5 into 2 is 10. Plus, so we will take it as a plus. Given is plus here. Plus 7I. 710I. This is the given equation. Therefore, it becomes 8 5 minus 4 3 minus of 15 5 minus 5 10 plus 7 0 0 7. 7 we have made it scalar. Therefore, it becomes we have to perform the operation. Therefore, 8 minus 15 plus 7. This is the first element. Second element is 5 minus 5. This because of this minus 5 plus 0. And minus 4 plus 5. Minus into minus is plus 5 plus 0. And then last item is 3 minus 10 plus 7. So simplifying, we get this is 8 plus 7 is 15. 15 minus 15 is 0. 5 minus 5 is 0. This is also 0 and this also is 0. Hence the net result is 0. We have proved it. Next problem. If A is equal to 2, 3, 0 minus 4, B is equal to 1, 5, 2, 0, show that AB dash is equal to B dash A dash. That is transposition. We have to do the transposition. Given A and B as written as it is. Therefore, A dash is equal to, we have to interchange a row by column. Therefore, row 2, 3 becomes column 2, 3 in A dash. Row 0 minus 4 becomes second column in A dash, that is 0 minus 4, and B is equal to, that is B dash is equal to 1 5. Row 1 5 becomes column 1 5, and row 2 0 becomes 2 0. Hence AB is equal to, now we have to find the value of AB. AB is A into B. A plus B, sorry. Two plus 6, 10 plus 0, 0 minus 8, and 0 plus 0. Therefore, AB dash is equal to, AB dash is equal to 8 minus 8, 10, 0. Therefore, BA dash is equal to 2 plus 6, 0 minus 8, 10 plus 0, and 0 minus 0. Therefore, BA dash is equal to, we have to find in the reverse way, 8 minus 8, 10, 0. That is AB dash. That is, this AB dash is equal to BA dash. Hence, we have done it. The 5 marks questions we will be taking up in our next video, that is 3C. Thank you. Please practice it repeatedly so that there is no confusion and you will be able to score 100 out of 100.